Hey everyone, welcome to The Explainer. So today we are tackling a massive headache that honestly almost every growing engineering team eventually faces. I'm talking about persistent storage. We're going to explore a really fascinating solution that's designed specifically for that tricky, often super painful space between your simple local setups and those massive enterprise clusters. It's a system called Odysseus Distributed Volumes, or DVM for short. Let me frame it for you with this question. What actually happens when your application outgrows Docker Compose, but your team simply can't afford to hire a dedicated Kubernetes platform group? Well, you hit a wall. You know the feeling, right? You're outgrowing a single server, and suddenly the infrastructure choices become incredibly punishing. You absolutely need high availability, but that jump in complexity, it's just staggering.
Okay, let's dive into this. Here is our roadmap for today's explainer. We'll cover the infrastructure valley, introduce Odysseus DVM, look under the hood, explore data sovereignty by design, run through some real-world use cases, and finally, check out the competitive edge. Starting off with Section 1, the infrastructure valley. This is that massive gap between beginner tools and enterprise behemoths. Picture this. It's 2 a.m. and your pager goes off. A local hard drive just died on your single Docker Compose host. There's no replica. Your database has literally nowhere to go. You are looking at hours of downtime, maybe a 4-hour restart from backup, and probably some significant data loss. This brilliantly illustrates the impossible choice teams are forced to make. On the left, you've got Docker Swarm or Compose. Wonderfully simple to start with, but ultimately kind of fragile. It's a single point of failure for your volumes. On the right, the heavy artillery. Kubernetes plus a storage layer like Portworx or Rook Ceph. Extremely capable for sure, but it inherits clusters of operators, custom resources, and it requires a heavy site reliability engineering headcount just to keep the control plane alive. Let's move to Section 2. Introducing Odysseus DVM. Resilient, persistent storage specifically built for this gap. If you are a technical founder or an infra lead running, say, roughly 10 to 200 containers across a handful of nodes, Odysseus DVM acts as your Goldilocks solution. It's the persistent storage layer right inside the Odysseus orchestration platform that gives you replicated, snapshotable, failover-ready storage, all without ever touching Kubernetes. And look at how remarkably simple the deployment path is. Step 1, install a single Go binary on each server. Step 2, write a few lines of YAML to declare your volume. Step 3, get your replicated, snapshotable storage. That's literally it. There's no separate control plane you have to install and no 60 acronym ecosystem to memorize. It's enterprise-grade storage delivered in an afternoon. Section 3, under the hood. Let's see how this builds on 3 really deliberate architecture choices. The engineering here is powerful, but without all the bloat. First up is the storage model. Unlike platforms where you're forced to bolt on external vendors for every different need, DVM actually has a built-in 3-tier system. Slice 1 is your hot tier. These are local POSIX volumes replicated via rsync for super-fast direct access. Slice 2 is the warm tier. That's a managed seaweed-fs cluster, automatically spun up for shared file workloads. And Slice 3 is your cold tier. Per-tenant Mini-O or S3 buckets for archival and backups. You aren't managing 3 different vendors. You just declare exactly what you need in your YAML file. Now, what's really interesting here is the operational economics. DVM's control plane targets under 150 megabytes of RAM. I mean, think about that for a second. If you're running heavy systems like Ceph, you're dedicating gigabytes of memory just to coordination. DVM drastically cuts operational overhead. It means you aren't paying for enterprise-scale control planes when all you really need is robust storage for a dozen containers on a few rented servers. Section 4, data sovereignty by design. We're talking architectural guarantees here, not just checkboxes. Any DevOps engineer evaluating a new storage tool is going to immediately ask, okay, but how secure is my data, especially when it's replicating across nodes? The answer lies in this concept, a metadata-only control plane. DVM is a system that stores only volume specs, sync intervals, and health metrics. It never stores your file bytes, your database rows, or your backup logs. All the actual replication traffic goes peer-to-peer using this automatically provisioned, fully encrypted WireGuard mesh. The control plane only knows that a replica is in sync, it never actually sees the data itself. So the crucial point is perfectly captured in this quote straight from their design documents. The vendor cannot read your data even if it wanted to. Guys, this is an architectural guarantee. Your customer data never leaves your hardware or traverses a vendor's infrastructure. For regulated industries, think health tech, fintech, public sector, that level of data sovereignty is just a massive advantage. Moving to Section 5, real-world use cases.
Let's prove DVM actually works out there in production.
Let's step away from the theory for a minute and look at how this behaves in actual stressful scenarios. 43 seconds. That is an absolutely incredible number. There was a B2B SaaS company running a multi-tenant Postgres setup on bare metal. At 3:14 a.m., an NVMe SSD completely failed. But because they used DVM, the failover controller detected the missed heartbeats within about 15 seconds, scored the most in sync replica, promoted it, and restarted the Postgres container on a totally healthy node. Total customer visible downtime? Just 43 seconds. That is fully automated failover happening while the engineering team slept.
Take another great example. A media ingest platform that handles 200,000 photo uploads every single day. They needed any app, container on any node to be able to read or write any photo. So they simply declared a shared Seaweed FS volume. DVM seamlessly managed the high-volume, shared fuse-mounted folder across all their nodes. And honestly, the best part? They achieved the whole shebang with absolutely no manual commands beyond typing Odysseus deploy.
Now, what's really interesting about this slide is how automated reliability builds a really powerful compliance story. Take a look at this timeline from a health tech customer dealing with strict 7-year retention rules for patient records. Day 1, the data lands on the hot tier, so local SSD. After 30 days of inactivity, the automated tiering engine just steps in. It performs a SHA-256 checksum verification to ensure absolute integrity, and then securely migrates the data over to the cold tier, a Minio archive, for the remaining years. It's automated, mathematically verifiable compliance.
Finally, Section 6, the competitive edge. Honest limits and transparent comparisons. Okay, let's just lay the cards on the table. When you evaluate a single binary install, built-in failover, and native cross-node replication, DVM clearly stands out against Swarm, Kubernetes, and Nomad, specifically for teams running 3 to 20 nodes. You know, the operator learning curve for Kubernetes storage is often measured in quarters or months, but for DVM, it's measured in days. It's operational simplicity tuned exactly for that mid-tier scale. But real credibility comes from transparent honesty, right? So here is exactly when you should not use DVM. If you need multi-region active-active writes, this isn't for you. DVM is single primary. If you're scaling way beyond 200 nodes, or if you need extreme IOPS pushing past 100,000 for incredibly write-heavy workloads, you should absolutely be looking at a dedicated storage area network or a massive Ceph deployment. DVM knows its lane, and it happily stays in it. Which brings us to our final provocative question. Are you ready for enterprise-grade high availability without the enterprise headcount? If you're an infrastructure lead stuck in that painful valley between fragile scripts and hyper-complex Kubernetes clusters, Odysseus DVM offers a fascinating, elegant bridge. I highly encourage you to go check out their design documents or reach out to the Delta Telematics team for a pilot to see if it fits your workload. Thanks so much for joining me on this explainer, and as always, keep learning.